right, so 13b, all we're doing is we're writing an equation. We'll do one in terms of sine, one in terms of cosine, and then at least one of them with a negative value of a, either one. Because again, if we could, it's pretty easy once you understand how to do one of them, how to do the other three of them. But anyway, the first thing we want to do is fill in all the missing pieces of information that we're used to seeing. So on this one, we have a high point labeled at 6 and a low point labeled at 5. Those are not horizontal asymptotes, but they are nice guidelines. So first thing I'll do then is find the midpoint, adding them together and dividing by 2, or this one's pretty intuitive, right? 5.5. Now, if you want, you can come down the side here and start collecting your A, B, C, D, P. We really don't need the range if we're just going to write the equation. But once I know that the center line is 5.5, that actually is one of our letters for our equation, isn't it? Which one is it? The sinusoidal axis is your, not A, A is the amplitude. Remember, it originally was down here, and then I moved it up to there, so it's your D value. Yeah, very good. So D is, that actually worked. Look, it almost lined up. It's pretty good for me. Anyway, yeah, it's your D value. So D is 5.5. So got that down. All right, now we've got a high point labeled at 15 and a low point labeled at 100. You could just assume that those are going to be marked at critical values. So first thing we want to do is figure out how far is it from 15 to 100. 85, right? 100 minus 15. So that's 85. And what you could do then is set that equal to the fraction of the period. It'll be in chunks of quarters, right? We saw yesterday was 3/4. This one from a high point to a low point, what fraction of a period is that? 2/4, right? Or a half, right? Yeah, it's a half. So that's a half of a period. So if a half of a period is 85, the full period is twice 85, which is known as 170. Okay. Now, knowing the period is 170 is nice because that allows us now to find our B value. Because remember, the period we need for and get from the graph, but the B value we get from and need for the equation. So the B is 2 pi over P. And I do want you to give a simplified value with pi visible. So if we simplify that, that turns into pi 85ths again, right? So now we have our B values. I'll come up here and put the B as pi 85ths. And let's see, the C value, remember, this depends. It depends on whether you're calling it positive or negative sine, positive or negative cosine. So really all we need is the A value and we've got it, right? So for the A value, how far is it from 5.5 up to 6? 0.5, yeah, so that's 0.5. Now notice I have a high point and a low point labeled. Which of the two trig functions always starts at an extreme, sine or cosine? Cosine, right? Yeah. So cosine, positive cosine starts high, negative cosine starts low. So I can go ahead and write a cosine if I want. Let's give this function a name. We'll call it f of x. Let's do positive cosine. What the heck? So positive cosine is going to be positive 0.5, the amplitude, cosine, parentheses, the B value, pi 85ths, times parentheses x. And if I want to scooch over to 15, is it going to be x plus or minus 15 in the equation? Minus, good, opposite. And then close, plus 5.5. So that works easily for a cosine. If you wanted to do a negative 0.5 cosine, it would be x minus 100. In fact, it doesn't take much to write that out. Let's just go ahead and do that. G of x could also be negative 0.5 cosine, pi 85ths, parentheses x minus 100, close, plus 5.5. But if I need to write one in terms of sine, sine always starts on an axis, right? And that would be right about here would be where it's on the axis going down, and right about here would be where it's on the axis going up. Those currently aren't labeled, right? So in order to label them, there's a couple ways you could do it. You can either say That one is the midpoint of 15 and 100, which is just their average. That helps you find that. Or you can just find the fourth quarter period, right? If the full period is 170, half of that is 85, then the fourth of the period is either a fourth of 170 or half of 85. What's half of 85? 42.5. Yeah. And now I know how far apart every critical value is. So let's see what this one is here. 42.5 plus 15 is 57.5. And 57.5 plus 42.5 is 100. And then 100 plus 42.5, that one's easy. That's 142.5. And now with both of them labeled, we might as well just finish writing one of each, A, B, C, D, E, F, G. Let's call this one H. And let's do a negative sign. So it'll be a negative 0.5 sine pi 85th stays the same. X plus or minus something plus 5.5. So once you get the value of A and the trig function determined, the only thing that varies is the shift, the phase shift. So for a negative sign, do I want to be on the axis going down or on the axis going up? Down, right? Remember, negative is always associated with going down or being down. Positive is always going up or being up. So I just shift over to 57.5. So minus 57.5. And then lastly here, we'll call this one, I'll use big F of X instead of little f of X for Friday of X. And now it's going to be positive 0.5. We'll do a positive sign. Pi 85th, X plus or minus something plus 5.5. And we just shift over to where it's on the axis going up, which is 142.5. So it's X minus 142.5. And that's it. Now we have one of each. We have one positive sign, one negative sign, one positive cosine, one negative cosine. Ta-da. And we ended on a positive, right? We ended on positive sign. Yeah, nice. Okay, the thing that once you figure this out, the thing that usually costs people points on quizzes or tests is just forgetting to have two sets of parentheses. You know, that last parenthesis where you're closing it off, sometimes that's accidentally left off, and that'll cost you. So one open on the outside, another one open on the inside, close, close, plus D. All right, comments or questions about sinusoids or snow leopards? Snow leopards. It didn't really sound like a roar, right? Ow! 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 It sounded just like its foot was caught in a trap or something, but I don't know. I've never seen a snow panda in the wild either. But then again, I'm not a snow panda researcher. But he is, and he hasn't. Can you imagine the frustration? He works in Connecticut, but he does research in Pakistan, right? Can you imagine, like, he tells his office mates in Connecticut, hey, I'm going to go out and do some field research. And they think he's like going out in the field behind the university, but he flies to Pakistan, right? That's it. And the college pays for it because he's doing research, right? Quote unquote research in that pristine wilderness. If you like that kind of thing. All right. Any comments or questions about math? I think we've answered all the snow leopard questions for today. How does the roar sound? Did I nail it? Yeah. It looked like it was hurting. Yeah. And if you're watching the video, just look up snow panda roar. Right, you'll get it. Okay. Bye, everybody.